Lecture 11A, Definition and Properties of the Torsion. The torsion is a tensor field of type 1, 2 at a point P belongs to the manifold M. This is a trilinear map, TP, TPM, TPM, and T asterisk M. This is a cotangent space. It's vector space in this case. This is R, this is real. You see, that's the definition of a tensor. You see, as we derived previously, you see this here, this is a vector field. You see, this is a vector field. This belongs to the tangent, the tangent vector space, and this belongs to the cotangent vector space, which maps in the real. That's the definition of a tensor. This is linear argument, you see, which is this case in each linear argument. Equivalently, it can be thought of as a map. You see, this is T, so this over here is a tensor field, okay? There's a tensor field. There is this case in C infinity M. This is a linear in this case in each argument. There is multilinear over functions, and its output is a smooth vector field. You see, the tensor field, you see, the output is a tensor field, okay? So this is a definition from the previous lecture, lecture 10, that this is covariant derivative minus covariant derivative minus this is a Lie bracket. Each term is a vector field, belongs to the chi of M, and this is a space, the manifold, you see. So T is chi M times chi M. This is a vector field. You see, vector field, this is a vector field. So the tensor maps two vector fields. Let's put an S here. Two vector fields to a vector field. You see, that's important concept in the definition. Now there are some properties of the tensor or the torsion. The first one is skew symmetry. You see, Txy is minus Tyx. From the definition, you see, you just write the definition here, then here is equal minus dyx minus dxy plus xy. You see, I just set here the minus here before this parenthesis. So the Lie bracket is skew symmetric also. So the Lie bracket of xy is minus the Lie bracket of yx. So you see here, this is exactly the torsion of y comma x. This is minus torsion of y comma x. Another important property is a multilinear of scalar functions. Linearity in the first argument. You see the linearity in the first argument. That's proof that this is linear. Why? Because when you prove that, you see that f comes outside. You see, that we'll call a linear, okay? A linear property, linearity, okay, of this first argument. And this can be proved, then you compute each vector field, and vector field. You see, compute the first one, the second one, and the third one. So we'll continue this proof in the next lecture 11b. You see, that's clear the definition of torsion, which is very, very important, okay, on curvature, as we see. See, that's it.